All things are one thing, and that one thing is all things. Plankton, a shimmering phosphorescence on the sea, in the spinning planets and expanding universe, all bound together by the elastic string of time. It is advisable to look from the tide pool to the stars, and back to the tide pool again.
Imagine an ecosystem as an arch. Every species occupies a stone that collectively holds up the entire structure. A keystone species inhabits the top of the arch. It causes an ecosystem to flourish, or, in its absence, to crumble. Sea stars inhabit tide pools and low intertidal benches, serving as an iconic symbol of California's rocky intertidal habitats.
Keystone species is any organism that is super dependent upon, where there's other organisms that will either go high in abundance with their absence, or if they're kept at a low enough level, then these organisms are maintained in their habitat.
Sea stars are some of these powerful species. Not just the big bright ochre stars that everyone is used to seeing in tide pools, but even the small cryptic sea stars hiding in the mussels are voracious predators, controlling populations of their food, such as marine snails.
Sea stars are very important for maintaining the biodiversity of intertidal habitats. They function as what's known as keystone predators, meaning they will eat, for instance, mussels, and by doing that they allow less competitive animals such as barnacles to coexist in that habitat.
In June 2013, the most devastating epidemic sea star populations had ever experienced took hold, killing hundreds of millions of sea stars. This is known as Sea Star Wasting Syndrome, or SSWS. It's an epidemic literally disintegrating sea star populations en masse.
Sea star wasting syndrome is a description of a variety of symptoms, including body wall lesions, writhing of the sea star arms, and loss of the arms and arm autonomy. So a lot of this has been described as the symptom throughout a bunch of sea star species. So sea star wasting syndrome has been documented and impacted over 20 sea star species along our coast here specifically. And the symptoms are caused by, debated among scientists, by a variety of factors, including a virus component or a combination of the host and the environment as well. So a lot of this is still being done today.
A scientist studying SSWS, Jen Burt, a doctoral candidate at Simon Fraser University and a Hakai Institute scholar, has noted the horrific scenes he has witnessed at the bottom of the ocean floor due to SSWS.
You would literally be swimming on a transect line, and you come across single sea star arms.
There has been debate about what is causing sea star wasting syndrome. Some possible answers to that question include a virus. This densovirus has been implicated in some outbreaks. Temperature has also been linked to an increase in disease incidence, and other factors such as salinity, pollution, environmental extremes are also theorized to play a role, but we don't know for sure.
Sea stars are vital organisms for intertidal habitats such as kelp forests, as they keep species like sea urchins to bearable levels.
Another result we have seen at some locations where the sea star population was hit hard by sea star wasting syndrome is an increase in sea urchins, which has led to decreased algae such as kelp. Some sea stars, mainly the large sunflower star, which used to be a fairly regular sight and now is extremely rare to find, eat sea urchins.
With the SSWS epidemic in 2013, the annual survival rate of small and medium sea urchins increased by 166%. The density of affected kelp forests, meanwhile, declined by 30%.
In a world where scientists still do not know what exactly is causing SSWS, one of the most important things you can do is fund research groups doing long-term monitoring of these ecosystems.
There hasn't been one single solution presented, though multiple different groups are working on ecological surveillance and categorizing the outbreak, which is the important first step in terms of a disease outbreak like this.
So people can help out by becoming scientists and helping people like us who are currently doing research on these organisms. So for habitats that we may not necessarily get to at the same time, it'd be great if people could go out, collect data, report back to an institution, and we can use that information to better inform how we go about our research or what is currently going on in systems when we personally can't go out to the field.